today's lesson. This will be posted probably in about an hour. The instructional objective is students will be able to identify the relative age of rocks. And I changed it to now. I don't know why it's not changed on this slide, but it's supposed to say, how can we describe, or what are some methods we could describe the approximate age of a rock with, right? So come up with some method for figuring out how old a rock is. Today's mini lesson, we're going to talk about geologic time, and then we have relative dating practice for labs 9 and 10, which is a combined lab, nice and long, but we'll work on it together, so it'll be a good one. So radioactive dating is problematic. It requires very big equipment, very expensive equipment, very difficult to come by equipment. And if you want to know the age of a rock in the field, you're not going to be using radiometric dating. And that's just what it comes down to. So it sounds like a great thing on paper because it's very accurate, but it's hard to get. So we have relative dating. Relative dating gives us the approximate age of a rock based on other rocks. So I don't know, Abdullah, I'm going to pick on you. Who's the oldest rock in this chart? Is it 1, 2, 3, 4, or 5? 1, because it's the lowest on the chart. The further down on the chart you are, the older you are. The higher up, the younger. So it probably goes 1, 2, 3, 4, 5. And then you have the section of mixed strata. The mixed strata is probably even younger, because you can see it cuts through 5, cuts through 4, cuts through 3. So we know it's got to be younger than all those. It's kind of like the idea if you have a crack in a wall, what's older, the wall or the crack? Obviously, the wall is older than the crack, because you can't have a crack in a wall without a wall. Okay, so this comes down to the principle of uniformitarianism. Ms. G? So if it rains today, it rained 1,000,000 years ago. If we have erosion today, where water sweeps things away, we had that 1,000,000 years ago. That's really what it comes down to. Because prior to him, we kind of didn't, it was more like stories, like the Great Flood, right? We had these big storms, whatever. Maybe that's what created the Earth. Well, he kind of said, well, let's just go with what we see happening now. So that leads us to the principle of original horizontality. Look at these beautiful horizontal lines. All this rock was dropped down one step after the other. And the nice thing about it, and the fact that we can go by the years and estimate the years on it, is because everything is just so flat. When things are flat, it makes dating very easy, because we know that rocks are laid down horizontally to begin with. Oldest on the bottom, youngest on top. Next up, we have contact metamorphism. So if you remember back from like 3rd grade or 4th grade, whatever, when you were first learning about rock types, you found out there was this type of rock called metamorphic rock, where when you heated it up, it recrystallized. When it recrystallized, it became a different type of rock. Well, you can see how this magma is flowing through all these horizontal layers. I know the magma is newer than the layers because it had to cut through those layers, just like our crack and wall analogy. So really what this tells us is anywhere hot magma touches, it's going to create a small section of metamorphic rock, and that is evidence that the magma intrusion is younger than the rock it cuts across. Oh, I'm sorry, I'm breaking up. Okay, so here's an igneous intrusion. We can see white magma cutting through, or white rock now, that was magma, cutting through this blue background rock. That blue background rock was there first. The igneous intrusion came later. Who's older, the black rock or the white rock? So the white rock has to be younger, right, the black rock has to be older, because the white rock went through the black. So in the image, you can see that we have this white sandy rock at the bottom, and in the middle, we have this brownish red rock. But look at the transition between the two. It's like a sharp line, like something was erased away. So what could have taken away that rock? Could have been a glacier, could have been a flood, could have been aliens, but sticking with what we learned about in this class, probably was just like a big storm or many storms over many millions of years. I don't know about an earthquake, but definitely some other natural disasters could have caused it. Windstorms over many generations. And really, our last one on here are index fossils. So index fossils are fossils that are all over the planet for a short period of time. They help us get a date because, for example, this trilobite guy, I know he only lived between 450 and 480 million years ago. If I ever find rock with a trilobite in it, I know it comes from between 450 million years ago and 480 million years ago. Doesn't matter how high up or how low it is, because yes, we can use depth in the ground to measure the age, but a fossil gives us direct evidence. To the Google Classroom, you're going to go to Classwork. And you have two sections here. You have one that says week of 12/7/2020, that's today. You have a copy of today's notes. You have a video on relative dating. If you are not sure how to do these steps, watch this video. It's highly effective in giving you the steps. This is one example. We're going to look at another one tomorrow. But I need you to then go down to labs, where it says lab 9 and 10. So lab 9, 10, it's a combination. It's a double lab. This will not be due at least until December 10th, December 11th. We'll talk more about when exactly it's due later. You don't have to go to this lab right now, because again, this is being recorded, and you can copy the answers off the recording. But I just want to show you how to do this. So lab 910, general instructions. You must use earth science terms, for example, erosion, deposition, uplift, subsidence. Erosion sweeping away, depositions when it gets dropped off. Uplift is those orogenies, mountain building events. Subsidence is when things sink. Right? So basically, you're going to use all these things that we've learned to answer the questions that you have below. Now I'm going to do the first 4 with you. Today's assignment, today's classwork is for you to only do block 5. Okay, so let's do one together. Block 1 says label each strata with letters A, B, C, etc. List the events, be specific, needed to make the pattern of rock. So, who is the oldest? Call it out if you think you know. Yeah, the rock on the bottom. So the rock on the bottom, I'm going to list it as label A. I'm going to put a big red A there. Now I'm just going to copy this and then paste it. So Control C, Control V. You don't have to do it this way, but I'm just going to save myself some steps. I'm going to label each subsequent rock unit. Well, we've said that the oldest is on the bottom, youngest is on the top, so I'm going to label it A, B, C. We have another event that occurred here. If you take a look, you can see that there's this curve that runs down and it cuts all the way through C, partially through B. We call this letter D. So we have to, technically, do this. We have to label each event. So let's put it in order. The oldest is A, then comes B, then comes C, then comes D. We gave the extra one on here. You can erase that away. On most of these, I gave you extras because I want to see how you do it, and I didn't want you to run out of room. So yeah, if you have extra lines, don't freak out like you did something wrong. Okay, so that was for block 1. Block 1 is pretty easy. Any questions on that? Okay. Block 2. Label each strata. Label each strata layer and structure, faults, folds with letters. List the events, be specific. Block 2. Draw arrows on the fault to show the strata's displacement direction. So if you remember, this was a normal fault. I'm going to add a shape. I'm going to add some arrows. One of these guys slid down. Insert shape arrows up arrow. One of these guys slid up. So you're just basically showing what happened. Okay, what else is going on here? I guess it's very much like the last one then, right? So let's insert text box. We're going to label this label A. Just like before, I'm going to make it a little bit bigger. I'm going to make it red so you guys can see it easier. Next one would be B. And the next one would be C. Cool. Something I'm missing though. What am I missing? Yeah, that's right. We're missing our fold. I'm sorry, our fault. So I'm going to label that one D. Fill them in. A, B, C, D. Questions on this one? Pretty simple, right? You just kind of have to get used to the flow of doing these. These are actually quite relaxing when you get a good flow with it. Block 3. Label the anticline and syncline. Oh wow, that's going back. What was an anticline and what was a syncline? So remember, anticlines are like buried hills. Synclines are those buried bottom, like upside down hills. So in this case, I'm going to come up with 2. I'm going to label this guy anticline. Just like before, I'm going to make it red. You don't have to do this part. I'm just doing this so you guys could see it easier. So that's my anticline. And down here, this is my syncline. Actually, it's S-I-N, S-Y-N-C. Okay, syncline. Cool. So what happened here? Well, insert text box. Let's label them again. These guys are A. These guys are B. And these guys are C. So you might say, well, okay, it's A, B, C. But then we really would be missing something. We have our anticline and our syncline. Combined, we call this a fold. Folds are whenever you have rock that gets heated up and bent, right? So if you remember back from 2 weeks ago when we first learned about folding, faulting, tilting, that's an example of a fold. All right, and let's move to the next one. So this is block 4. So you can see this is quite a bit. There's a lot going on here, but don't freak out. Step at a time. Start with the oldest, move your way up. And remember, if you make a mistake, you could always change it. God knows I make mistakes on these all the time. So who's the oldest? I would say the oldest is definitely F. He's all the way at the bottom. These are nice because you don't have to label them. They're already labeled for you. After F comes C. Then comes G, then comes D. C, G, D. Okay, something happened. Notice we have an anticline, a syncline, and an anticline. So what do we call this whole process where the rock gets bent up like this? Beautiful. What happened after the folding? You'll notice we have this smoothed out bumpy line, I guess you would call it, that separates letter E from letter G and letter D. Like, what happened to the top of G? Isn't G supposed to be smooth? What happened to most of D? Look, I see some D here, I see some D here, and I see some of D here. They got erased away. It's almost like something swept it away. We could call that erosion, but more specifically, we would call that an unconformity. An unconformity is a missing layer or missing section. So how much is missing from there? I don't know. It could be, tons, but something's missing. Okay, after the missing layer, I now have E. E is pretty flat and boring, so it's probably just E. Then comes A, flat and boring, then H, then B. So E, A, H, B. E, A, H, B. And at the end of B, if you really want to be thorough, I guess you could say erosion at the top. And then the rest of these we don't need. All right, there you go.